Welcome back everyone. In the last lecture, we covered different operations on linked list such as insertion, deletion and traversal. Today we will take into the first step further by exploring real world application and variation of linked list. Understanding this concept will help you see how linked lists are used in practical scenario from memory management to complex data structure like stacks and queue. Okay, we will explore this in the next lecture what is in by stacks and queue. Okay, so without wasting our time, let's get started. So we are taking up four real world application of linked list. The first one, that is dynamic memory allocation, then implementing stacks and queue, then we know undo and redo functionality in applications. Okay, and the last one, that is graph and hash implement. So let's start with dynamic memory allocation. Okay, unlike array, linked lists allow efficient memory allocation and deallocation without worry about fixed size. Like operating system use linked list to manage free and allocated memory blocks. Okay, and about the implementing stacks or queue, you know that what is meant by a stack, that is LIFO. LIFO means last in first out. Okay, can be efficiently managed using a single linked list. While a queue means FIFO, FIFO, first in first out. Okay, benefit from a doubly linked list for easy insertion and deletion at a both end. Okay, this is for the both end. The next one, that is undo and redo functionality in application. Okay, everyone know what is meant by text editor and all that stuff. Okay, everyone use the software like Photoshop uses linked list to track changes. Each change is stored as a node, allowing user to undo or redo action by moving forward or backward through the list. Okay, everyone use the application. All application that you are using day to day life, you can undo and redo as well. I'm using PowerPoint, so I can undo as well in this and redo as well. Okay, the next one, that is graph and hash implementation. Okay, it's commonly used like adjacently list to represent graph efficiently. They are also used in hash table for handling collision through chaining, where multiple values mapping to the same index are stored as a linked list. I hope you get these four applications. The next one, that is variation of linked list. We already covered it, that is types of linked list, but we are again taking it. Okay, that is doubly linked list, circular linked list, skip list and self adjusting links. That is, a doubly linked list has two pointer. In, like, I will write it here, that is two pointer. Okay, one pointing to the next node and another to the previous node. That is, first one is a next node. Just a second. Yeah, next node, and one is previous node. Okay, two pointers. Okay, this make traversal in both direction easier but increase memory uses. Like it's get more time or type of memory uses, or we can say he get more uses of memory. Okay, the next one is circular linked list. A circular linked list is connected the last node back to the first node. Okay, forming a loop. It's basically loop, we can remember it like a loop. Okay, this is useful in application like round robin scheduling and buffering system. Okay, and the next one, that is skip list. Okay, is a variation where multiple level of linked list allow fast searching, similar to balanced binary search tree. Okay, it's uses in database and caching system like Redis. Everyone know that. Okay, Redis example. Redis example. My laptop is lagging, that's why it's take a little bit buffering. Okay, the next one, that is self adjusting list. In frequently accessing list, a move to from linked list, rearranging element based on accessing frequency. These help in optimizing caches, performing and searching optimization. I hope you get this variation on of four linked lists, that is doubly linked list, circular linked list, skip list and self-adjusting link. So today we will explore the real world application and variation of linked list. These concepts are foundational to many advanced data structures and algorithms. Before moving on the stack and queue in the next section, we will implement all the linked list operation we covered so far in the code. Okay, and we are taking the as well implementation of code of array, hash table, that what we cover up to this. We will take a whole implementation code on the next lecture, that is lecture number 50. So make sure to review today concept, and I will see you in the next one. And make sure to like, share and subscribe for getting more DSC using C++ series. Bye bye.